So I'm going to talk about centering in HLM, and questions have come up about this mostly because the HLM 7 software actually asks you to um, specify how you want to enter your variable. And so far we've entered variables uncentered. And this is the same thing as just putting in a variable into a regression and not doing anything about how it's presented. So why do we discuss centering at all? It's important to have a precise meaning of your variables so that your statistical results can be related to your theoretical constructs. And in HLM specifically, your slope and your intercepts at level 1, so your beta j's, become outcome variables. And so the meaning of these outcome variables needs to be understood clearly. And in some cases, proper choice of location or centering is necessary to ensure numerical stability in estimation. What does this mean? That means that sometimes if you mean center, for example, your variables, your computational benefits will be great, especially looking at cross-level interactions. So it could be that you might have to actually center to get convergence of your model. So when you're centering level 1 predictors, there are really four ways that you can do this. You can keep them as is, which is what we call a natural metric. We can center it around a grand mean, which is the sample mean. We can center it around the group mean, and obviously each group will have its own mean. And then there's other locations. Now, in general, if you've centered variables before, you probably centered continuous variables. But there's also the possibility of centering dummy variables, and I will talk about this as well. So the natural metric, when do you use this? You use it when there is a meaningful zero. For example, number of cigarettes smoked per year. Otherwise, you will produce a meaningless intercept and nonsensical effect. So from the last exercise and homework, there is no way that anybody can be in age group 0. Um, so there is no meaningful 0 age group. So similarly, this applies to Likert scale. This applies to SAT scores where you get a certain number of points for just putting your name down because the natural 0 is actually not at 0. And then it depends on what you're interested in. If you're looking at age, for example, sometimes it's easier to interpret the natural metric by using the number of years people have been on the planet. Sometimes you want to have a comparison group. Let's say we're talking about cancer screening for cancer type where screening is recommended starting age 50. Then maybe you want to start at age 50 and then say every year after that time point is what you want to model. So it depends on your research question and it depends on your variables. So let's talk about grand mean centering. This is when you calculate the mean of the entire sample and you subtract that value from the person's individual value. And the notation here is this is X bar with two dots on the bottom, indicating that it is across everybody. And if you're doing this in HLM 7, you just say, please enter this variable grand mean centered, and it will do it for you. In any other software package, you will actually have to do the math, which means you will have to calculate the mean of your sample and then subtract that number from each of the values. But what happens then? So then the intercept is interpreted as an adjusted mean for a specific group. And the variance, tau 0, 0, which is your intercept variance, is the variance among the level 2 units in the adjusted means. So what are we getting? We're getting an individual deviation from the sample mean. So let's say on average the group is 50 years old. If you're subtracting this, somebody who's 49 gets a -1, so 1 year younger than the sample mean. Let's say we're doing, let's take a medical example. It's a little bit easier sometimes. Body temperature. So if you're below or above the norm, which is this, is going to be the population mean or the sample mean, then you can talk about somebody who's a little lower, somebody who's a little higher. This also works well for Likert scale. So somebody who is less happy with the intervention, let's say we're doing a process evaluation, for each point below the mean satisfaction, we're seeing a certain decrease in intervention effectiveness. So that's important if you think that the overall mean of the sample is meaningful to be kind of the guidepost of an individual's value. So is that individual lower or higher than the sample mean? So the other option then is group mean centering. So with grand mean centering, we're comparing an individual's deviation from the entire sample. Group mean centering is the same concept, but we're comparing now somebody to the mean of their group. So how do we do this? Let's do this first. How do we do this? So HLM 7, you just tell it, but let's say you have to do this from scratch. You would have to calculate the mean for each group, and then for each member in the group, you would subtract that mean. And what does that give us? It tells us how much deviates an individual score on a predictor from their group mean. This is incredibly important for a lot of the research that we're interested in if we're thinking about context. So how much does a person's caloric intake differ from their family mean? So is that person just right where the family is? And then, or is that person very different from where the rest of the family is? Um, if a person's exercise level is related to the neighborhood they're living in. So where is the absolute level might not be important, but it might be important compared to others in the neighborhood. How is this person doing? Is this person higher or lower or right at the mean of the group? This is important in research that looks at norms. So if we're looking at community norms, many times we have people who are different from the community norm, and that can lead to repercussions. So if you're very different from your community, you might be standing out a lot, and that might be a problem, and the community might want to rein in your behavior. So again, in these cases, group mean centering is important. What we're also then doing is in group mean centering, it is best practice to then use the group mean as a level 2 variable, because then you still have these two pieces in there. And I know that somebody already asked this. If we're doing this, this is not double dipping. You can actually show with a mathematical proof that if you parcel out an individual's deviation from their group mean and put both variables in there, that they're actually statistically independent. So there's no multicollinearity, there's no double dipping, so you're fine on that. However, we already talked about aggregating to the group level, and so anything and everything we talked about in that regard obviously plays a role, because if you only have a few people representing a community, then your group mean is not a great measure of the actual group, the group's mean in the population. So you want to pay attention to that. Also, if we're talking about societal norms, let's say we're talking about societal norms around men who have sex with men, and you only have data from men who have sex with men, then that might not be a good indicator of the community norms in general. It might be a good indicator of the community norms of the MSM in the community. But keep those things in mind. But there are many, many applications where group mean centering is the way to go, because this is actually how we're thinking about the world. There are other locations that might make sense for a level 1 predictor to be centered on. Sometimes there is a reference group. Youngest or oldest age group might be something. With the SAT, I have no idea what the minimum these days is. That might be the meaningful number. It used to be 200, I think, that anybody got actually showing up. It could be at a population value. Remember, going back to my example about the body temperature, we might actually want to compare even a group of people, let's say, who have the flu, to how far are they off what is a healthy body temperature. And then there could be a certain time point, and we will talk about this when we get to the longitudinal models because there's meaningful ways of centering in terms of time as well. Dummy variables. So I want to talk about this because this has come up, and Raudenbush and Breiker are the only ones that I know who have addressed this in writing. And they call it quite useful, and I know that there are some applications that might make sense. So gender. Let's say we're having men and women only. So we have a binary gender variable, males coded 1 and females coded 0. And then if we grand center that, then instead of having the score for a female in there, it is the proportion of male students in the sample. And for a male, it will be equal to -1 minus the proportion of female students. And so we therefore can model on an individual level for a female and for a male some form of an exposure. I'm not fully sure about the application of this because all it's going to be is going to be a differently scaled variable because it's going to be the same for all males and all females. But having said that, if you stumble over it, you won't be completely surprised. If you find a meaningful application of this in the literature, please share it with me because I don't have one. So, what if we're centering gender around group means? Now, this might be a little bit different because remember also we were talking about aggregating to the higher level. And I've seen people calculating a proportion of males or females in a neighborhood, and that is related to sexual risk-taking behavior. That is something that people like Hannah Cooper and Danielle Haley have done, especially in a lot of minority neighborhoods where there's a lot of men incarcerated. There's an imbalance between women and men, and that leads to transactional sex rates. No, it doesn't lead to, but it's related to things. And so if we're looking at HIV risk environments, that is something that some people model, and then it might make sense to actually look at what's going on there. So then it would be, in this case, the proportion of male students in this group, or in this case of what I was mentioning, men in the neighborhood. And then the same for the men, just 1 minus the proportion of the women in the neighborhood. And that doesn't change your interpretation of your beta 0J. But as I've shown in this example, there are actual applications in the literature that look at that. I can see applications in, let's say, STEM learning environments, let's say classrooms, because we know that if we have more boys than girls in the classroom, especially it's like something like physics or computer programming, the dynamics will change so that the environment actually interacts with the gender of the person, and there's impact on behaviors and learning. So there are for the group mean centering, I can see applications in a couple of research areas. So let's come back to general recommendations. In general, your level 1 centering needs to be based on your research question, and the goal is to have meaningful interpretation of your estimates. However, keep in mind for level 1, the estimation is influenced by your centering choices. So once in a while, you might actually play around with centering, with grand mean and group mean centering. It's mostly group mean centering to see if your estimates might actually turn out better if there's problems in there. But then you also have to go back and say, what are the problems in the data? Is there something in the modeling that I have to change the centering because the centering changes the interpretation? Level 2 centering. You have 3 choices. You have your natural metric. We now have only mean centering because there's no clusters above in a 2-level model. And then other meaningful locations. The choice of your location is not as critical as numerical instability is less likely and interpretation might be not as complicated. But there could still be issues with numerical instability if we have cross-level predictors. So there could still be something going on if we're looking at cross-level interactions.